Okay, so in this video we're going to be talking about pH. What is a pH? Well, most of us have heard of substances getting tested for pH, and we know it has something to do with acidity or acids. And those of us who have taken general chemistry will remember that acids are proton donors overall. I'm oversimplifying here. But basically, acids are proton donors and electron acceptors. And also, those of us who have taken general chemistry will remember the mnemonic oil rig, which stands for oxidation and reduction. Oxidation is loss of electrons, oil, and rig, reduction, is gain of electrons. So if acids donate protons and they accept electrons, then they'll tend to draw electrons off of things. So they will cause things to lose electrons. They will cause things to be oxidized. So acids will oxidize things. And the acids themselves, as they oxidize, will become reduced because they're going to lose protons and they're going to gain electrons. So they're going to be reduced. Okay, so that's a quick reminder of exactly what we're talking about when we talk about how acidic something is, or how much acidity it has. We're talking about how many protons it has to donate. We're talking about its tendency to accept electrons. We're talking about it being an oxidizing agent, and we're talking about a substance that will become reduced in chemical reactions. And so what does that mean for a pH? Well, a pH is basically the negative log of the proton concentration. The negative log of the proton concentration. So when we say that pure water, H2O, has a pH of 7, what we're saying is that 7 equals the negative log of the proton concentration, or the negative log of the proton concentration equals 7. And another way of saying that is that negative 7 equals the log of the proton concentration, or the log of the proton concentration equals 7. So what does that mean? Well, let's look at a couple of examples here really quick. Here we see a few examples. And if we look at the first thing on the list, lemon juice, that has a proton concentration of 0.01 moles per liter. And just a quick reminder about scientific notation, 100 equals 1 times 10 to the 2, or 10 squared. And 0.01, or 1/100th, equals 1 times 10 to the negative 2. So if we take a look here, down below, lemon juice has 1, 2 zeros before the 1, and so that's 1 times 10 to the negative 2. 2 zeros before the 1 if you include the 0 before the decimal, that is. That's an important thing to remember. So in scientific notation, that's 1 times 10 to the negative 2. 1 times 10 to the negative 2, which means it has a pH of 2. So up here, that means 2 equals the negative log of 1 times 10 to the negative 2, which, if you know your logs from algebra, that checks out mathematically. All right, so I'm just going to erase that real quick. If we look at black coffee, kind of the same thing over here. You can just count the zeros, starting with the 0 before the decimal. 1, 2, 3, 4, 5, and then your 1. 1 times 10 to the negative 5. 1 times 10 to the negative 5 for a pH of 5. Same thing with pure water that we just talked about a moment ago. It has 0.00000001 moles per liter, so in scientific notation, that's 1 times 10 to the negative 7 moles per liter, which means it has a pH of 7. Human blood, 0.00000004, or 1 times 10 to the negative 7.4 moles per liter of protons, or that's the proton concentration rather, for a pH of 7.4. Same thing with seawater. Its proton concentration is 1 times 10 to the negative 8 moles per liter, so it has a pH of 8. Baking soda, 1 times 10 to the negative 9.5 moles per liter for a pH of 9.5. So that's the relationship between pH and proton concentration. So you'll notice water, which we generally consider neutral, but the truth is it can be either an acid or a base depending on circumstances. It's all relative to what other substances are present at the time. So relatively to other things, water could be either basic or acidic, and well, actually that's true for almost any substance. But we're going to keep things simple here. So water is generally considered neutral. And anything with a higher proton concentration or a lower pH, so that's an important thing to remember. The higher the proton concentration, because we're dealing with a negative log here, the lower the pH. And the lower the proton concentration, the higher the pH. So things that have a higher proton concentration or a lower pH are more acidic. Those are what we're going to consider acids in the majority of environments that we humans would normally encounter. And anything with a lower proton concentration or a higher pH than water is overall going to be considered a base. And again, I'm keeping things really simple here. Depending on circumstances, this is all subject to change because it's relative to what kind of chemicals you have around at the time and what their various levels are. But for most common everyday purposes, water is neutral. Anything with a lower pH than that is acidic, and anything with a higher pH with that, or higher pH than that, is basic. And so as far as the calculations go, how to get a proton concentration from your pH, or how to get your pH from a proton concentration, I am going to tackle those in smaller pieces. I'm going to try and keep everything in little bite-sized chunks so that you don't have to endure too much of me explaining stuff to get to the information you're looking for. So I'm going to try and break all this stuff up into smaller videos. So yeah, as far as how to do those exact calculations, we'll tackle that at another time in a different video. And that's it for now. So don't forget to like, comment, and subscribe. And oh yeah, don't forget to check out my website. You can check out my personal website at https :// or you can check out the science website that I webmaster at genesispanthesis.org. And yeah, that's all for now. So y'all have a good one, and peace out.